Buenas tardes. Mi español no es tan bueno, entonces yo voy a hacer la presentación en inglés, pero cualquier duda pueden preguntar en español. Yo comprendo más o menos que como soy brasileño, son lenguas muy cercas. So here we have all the main motivations, main goals for the automation in tunneling. Basically, we need to increase production, reduce cost, and improve health and safety. These are the main drives for almost in every case. To increase production, the most easy way is to put the utilization and availability of the drills higher. Cost, operation, and capital are, how can I say, you have to have the control on it. So with control, you can increase the use, and health and safety nowadays are the main drives of the main drives in industry. Not only in industry, but you can see in almost everywhere. Well, there are some years that in the drilling there are mechanized rigs, but let's say in 10 years, from 10 years to here, automated drills are increasing in the market. Unfortunately, I can say that here in South America, Brazil at least, and some countries that I've been, the automated drills are not the main ones, but still we are slightly growing the market. But the main drives today, almost every time when we speak with customers, they ask for automation, they ask for remote operation, and about monitoring of the process. First of all, the first things to be automated is the navigation of the equipment. The most simple navigation is the drill bit navigation, in which one the operator simply points the feed to the direction that he needs to drill, and then start drilling, basically. Or we have also laser navigation and total station navigation. Laser navigation, you just create a laser. It can be used in a total station or just with a pointer. And you put some targets at the feeds, and that's it. It's easy, but not so precise. One of the most precise are used in the total station. In the rigs, you put prisms at the rigs and measure using the total stations. So once you have all the points of the rig, it's ready to navigate. But talking about real automation, the state of the art is this point cloud navigation that uses a 3D scanner. Basically, you can scan the face, can scan the tunnel, and it creates, for example, the tunnel is not very smooth, so it has its own, in each point, its own rugs. It's something similar to a fingerprint. So once the scanner scans, it can see where it is. So as I was saying, this is the state of the art of the navigation. Generating the 3D point cloud, then you can see exactly where the rig is. You need 2 scans, normally in each boom, in each side of the rig. And it's a completely automated navigation of the equipment. So, for example, when you use the laser navigation, you need the laser, you need someone to use the total station, or so then you have to pass the data to the operator, and then he can navigate. But with this navigation with the scanner, you don't need no one for that. So in one step, you are taking out people from underground. So this can increase not only precision, but also safety. And of course, the operator will be inside the cabin all the time. Here's the point cloud, and once you are reading, scanning everything, also you can see where occurred overbreaks and underbreaks. And you can also analyze everything that the operator did. The operator or the rig, because the rig can also be automated. Well, one of the main difficulties in underground to automate the machines, the drilling machines, is about the bits here, because the operator always have to go outside the cabin and change the bits manually. So this is one of the new things, this bit changer. So basically it's a module attached at the feeds here. And with one feed, you can put it at the other one, like this, and you can change the bit. It's not automated yet, but it reduces the increase the safety. So the operator doesn't need to be outside. It's semi-automatic. The boom can move close to the point to change the bit, but it won't change it entirely. It has to be manually. As our colleague said, not everything can be automated. Also for rock support, we have basically the same. We can automate the drilling for the bolts, and the machine basically drill the hole, and it can install the bolts, everything automated. For example, here you can have the drill pattern, so the machine can drill it automatically. Doesn't need the operator to drill it effectively, but anyways, you always have to have an operator there, because it has to be supervised by a human. You cannot just leave the unit, the rig, drilling and operating by itself, let's say. You can do this with a jumbo, a face drilling jumbo, or also you can do it with a jumbo specifically for the rock support, that the line DS lines. Long hole drilling, it's basically the same you can attach another model to the machine with up to 4 rods, and the machine can insert all the rods by itself, so you will have longer holes. And I can say that this kind of operation, when done manually, is very, very unsafe, because sometimes the hole is in a higher position, and you have some operators in a high ground level, and of course outside cabin with a face that has noise, that has vibrations, so some rocks can fall from the roof. This can be done up to 30 meters. So, for example, once you have only 4 rods here, if you want to go further than the 4 rods, of course you can add some more manually, but of course, most of the time it won't be manual. For casing drills, it's basically the same for the long hole drilling. You will need only that module attached, so the machine will have more rods to add. Everything can be inside the cabin. And the rod adding, rod lifting, will everything be automated. The operator can just supervise everything. Of course, some of the things maybe the operator have to interfere, but almost everything is done automatically. The most important thing, and let's say that the one that takes much of the time, is the full face drilling. So, for example, to drill a face with 10 meters high and 14 meters sides, you can take up to maybe 3 hours or more, and with operators every time. So, for example, if you have a lunch break, so you have to stop the drilling, and that's it, unfortunately. So if you have a full automated face drilling, you can leave the machine drilling the face drills. Of course, not every hole will be done automatically. Some holes, for example, in the contour, once the walls are not so smooth, it's not every time possible, but you can increase the downtimes. So once you would have your operator or the operator in lunchtime and the machine stopped, then maybe you can do, I don't know, 5, 6, 7 holes with the drill in a time that's unproductive. And of course, another thing about the automation is that you standardize all the operations. So if you have, for example, 4 operators, each one in each shift, then one operator operates in one way, do his job very good, for example, and you have another one that's not so good. When you automate everything, then you can predict better, and you can have a control about a control of the quality of the drilling. So automation is not only about getting better time, it's also about being more predictable. The results will be more predictable. And one of the most important things is about the bone collision system avoidance. Because once you have a machine with 2 booms, 3 booms, then and the holes, sometimes they are not every time synchronized because the rock is not, is not so easy to predict. So you need this boom collision system. So the booms, while drilling, won't collide. Just before colliding, the machine will stop. So this is one of the needs of the operator to supervise the drilling. Because, for example, if it's in automated mode and one boom is going to collide with another one, the machine will stop. So you have to have an operator there. This is the screen to the operator. So it's a very, very easy to use. You can see every hole, and here in blue, for example, you have one boom. In green, you have the path that you have to do with this boom. Here, boom 2, for example, and in red, the path to boom 2. And this is what the rig is going to do with the booms. So also, the operator can anytime go and program it, or stop it, or make it different. Here is the user interface, just joysticks, very easy. The legacy units, we had hydraulic controls. You had a lot of hydraulic controls, at least 4 for the booms and 3 for the drifter. Here you have only 1 for the booms, 1 for the feed, and 1 for the drifter, which makes it very easily. And again, here the user interface, it's a touchscreen interface. So I always say to the operators, if you can use a smartphone, then you can easily learn how to operate a jumbo with this kind of system. And also the drilling control for the rock drill. Once the rock is, as I said, is sometimes unpredictable. Of course, we always do probe drillings and try to predict what is coming, but every time, sometimes you can have water, sometimes you can have some cracks. And here goes the automatic control of the drills. So for example, if the rotation is too high or higher than the normal, then the system will interfere and take the actions that it needs. For example, reducing the percussion pressure or the rotation pressure, whatever it needs. One of the best things that we have here is that we can increase a lot the life cycle of the tools. So for example, for the shank adapter, we can have sometime up to 30,000 drilled meters with one shank. And I can say that the normal life using manually can be up to 4,000, so it's really increasing the lifetime. And of course, once you have, for example, boom collision, anti-boom collision, the machine itself will have less damage at the booms, less damage at the drifter. Also, here you have, for example, several types of holes. So you don't drill exactly the same everywhere in the face. So cut holes, you will drill in a way, less percussion, less feed pressure. Easier holes, that are those, most of the holes, you can drill it faster. You don't need so much precision on them. But of course, contour holes, you will need to take more care about it. So, for example, if the machine is just in manual mode, then the operator can drill with every same pressure in every hole, because no one will see it, for example, and it sometimes, most of the time, is faster. Just use more pressure in everyone. But once it's in automated mode, you can program every hole or every type of hole to have its own kinds of pressure. So you may use lower pressure here, lower drilling height, so it can be done more smoothly, and the result of the drilling will be better. And at the end, even if the drill is in automatic mode or manual mode, you will collect every information of the rig and see at the office with software. So you are not only monitoring just the rig, you are monitoring about everything. So you have proportional control on the drifter. You can adjust every kind of every type of, for example, speed, the boom speed for every kind of operator. So there are some operators that like to use the booms in a faster way or slower way. It's very possible. You can, for example, use different profiles for the operators. And when we are talking about legacy machines without any kind of automation, it's not very possible, because you have to adjust everything directly on the hydraulic valves. So once here is everything in the system, then it can record every kind, and you have 3, 4 profiles, and it's very easy to change each one. You don't need to go directly to the valve and change it. You just need to start your preferences at the system. And once I said that you have a lot of hydraulic valves, hydraulic controls, for example, you cannot do in manual mode sometimes more than one movement with the boom. So you would do something like this to move from one hole to another one. Once the drill is in automated mode, or even in manual, but it's a intelligent machine, then you can do it with 2 or more movements at the same time. So, for example, you can use it even in semi-automatic mode, let's say. Then you can just move the booms and let the machine put the feed on the direction that it should be. So you can do one part that the operator can do faster, and the other part that the machine can do faster, and get the best of 2 worlds. Talking about safety, once this is an automated machine, then you have to have some protections controls. One of the easiest ones is just have, we can say that it's a laser at the side of the booms, and if someone cross this line, then the machine will be shut down, and you have to go to the emergency button and reset it. It's the machine won't be back to work so easily. Someone has to go there and change it. Of course, you can, for example, in manual mode, you can use it just as a detector. So if someone enters in this area and the operator is seen, then it will be a message on the screen, and the operator can say, okay, I see that some guy passed and I am seeing him. So as I said, you can have best of two worlds. If it's in full automated mode, then the machine shuts down. If it's manual mode, it can shut down, or it can just warn the operator that something different occurred. Someone entered the automated area. And the diagnosis, very simple also. You will have everything in just one screen. Almost every sensor of the boom, every drilling sensor will be in one screen, and you can see if something is going out of the procedure or is something strange. Then here will be a red light saying that something occurred, and you can see what happened. Of course, not always the system will say exactly what occurred. For example, if a sensor is bad, then the system will say, occurred something with sensor X, and please see it if the voltage is okay, or if there is some broken cable, or the sensor is broken. But it will say that some of the sensor is not good. Here is the part that I said briefly, that not everything can be automated. So here is what should be done. But once you have a rock here, you cannot put the feed in this position. So this cannot be done automatically. This is an example on how the operator should interfere. And so he will have to put it in a higher level. But anyways, the system will recalculate the angle so that the end of the hole will be at the same point that it should be. We won't have the hole exactly at the starting point, but at the end, which is very important, it will be at the right point. Talking more deep in digitalization, we can go to the tele-remote drilling, which we can take almost completely out the operator from the underground. So you can have, for example, the operator can go with the machine to the face drilling, navigate it, and once it's connected to the intranet, someone can operate from the surface, or if not from the surface, at least from a safer point at the tunnel. This is a very interesting thing, at least from not only for tunneling, but also for the mining. So sometimes in a region of the mine, you have very unsafe conditions. So you can have the operator in a safer place, inside a container, for example. And here, of course, you can do what we call it the hot seat. So if the operator has to go somewhere, has to do the shift change, has to lunch, then easily other operator can sit and keep operating. So in some places that the automation is not so simple to use, then you can go for a tele-remote drilling, for example. So every kind of digital solution, you have to analyze and use it as better as possible. Here is an overview of the automatic and remote drilling operation. You can have, for example, drill rigs underground. You can have drill rigs on the surface, and everything connected to the same system. So you will have an overview of every and each machine that is in your site. Here is talking more deeply about that data collection. For example, for the jumbos, everything starts with the tunnel, projecting the tunnel line. Then you can project the drill plan, put it inside the rig. You can project the vibration of the blast. As well for the bolting, you can design it as well for the face drilling, bolting and injection. Once you have drilled and blasted, you can scan with the scans on the rig. Then here you can see in green where it's okay, when you have under brakes or over brakes. And here you can collect all the data of the drilling. So you have percussion pressure, you have feed pressure, you have rotation and the penetration rate, which are the most important ones, but not only these ones. And here you can see smoothly how is the rock, and you can predict, maybe you can predict what is coming with the probes. Here you can see in each and every hole how much time the operator did in every step of the hole. For example, drilling, moving the boom, changing the beat, whatever you need. After, you can compare the vibration analysis from what you predicted here. You can compare and see your pull out. Here, every data of every hole, you can just change. For example, I want to see the percussion pressure. Want to see if the operator did the contour holes with less percussion pressure. Then you can see here it's in blue. Blue means that it's in a lower, and the inside holes are in higher pressure, which is okay. And you can compare every and each hole that the rig did. Auto mode or manual mode, whatever, you can see. So, for example, in blue, you have the projected holes, and in red, the ones let's say, as-built holes. So, for example, this one, you can see that for some reason, they were a little bit out, which is normal, but you can see that most of the holes were exactly how you projected. And of course, see the efficiency of the drilling. You can see round per round, you can see operator per operator, you can compare the drill in auto mode or the drill in manual mode. See how much time, for example, the operator is using between the navigation and the start of the drilling. So you have everything of everything of the data from the machine. And to control everything, not only the drills, you can have the fleet management that can be expanded for every kind of machine that you have on your site. So you can have the mine visualizer in 3D. If it's a construction site or it's a mine, it's same. The drill plans, this all in a web interface, so you don't need to have some specific device for that. You can see on web everywhere in the world. It's possible. The scheduler, so you can schedule each one of the actions. The jumbo one has to be drilling the phase A. So you can see here, and at the task management, you can see how is it working. So once the operators reach this phase, then he can say, okay, I'm the phase, I'm starting my job here. And you can compare what's going on, and if it's as you've projected. And one of the newest ones is the location tracking. This module is for both equipment and people. You can install let's say some black box at the equipment, and once you have, for example, Wi-Fi in your site, then it will know where the equipment is. Again, it's not only for the drilling equipment, it can be for any equipment. And you can put, for example, a special lantern to the operators, so you will know where the operator is, and for some reason, if a loader, for example, is driving, and one operator goes very close to this loader, with this lantern, then it can shut down the loader. So it's for safety reasons. If your operator is steady for a lot of time, then it can show a warning here on task management to the surface and say, you have an operator that's not moving. Maybe you have to check him. Maybe occurred something. Maybe he fell down, wherever. And the reports everything, condition of the equipment, drilled holes, how many tons of rock the loader has produced. Everything will be here, and you can see if each of your equipment is done their jobs well and done as projected. So you have control of everything, and at the end you can analyze everything, show in dashboards, so you can have screens at the surface with each graph about each machine or each fleet of machines, like my jumbos are in 80% of utilization, my loaders have moved 90% of what it should move in this week or this month. Basically, it's that. Thank you a lot for the attention.